Hello. I'd like to welcome you to the third of this series of theory panel discussions, I guess we call them. This one is about the history and the future of AI. These are a series of discussions which are going on every Sunday at the same time, 9 a.m. Eastern Time, 3 p.m. in Europe, in Central Europe, and 10 p.m. in China. And the idea really is to try and to open up the question about the theory of artificial intelligence, or in AI in particular. There are a series of these we've had so far. The first initial discussion on what is AI, and then AI and consciousness last week. And then next week we go on to move on to AI and creativity, AI and neuroscience, then into the architectural domain itself, with one session about the architectural design, one about the use of AI in the office, and then the use of performance-driven AI in the office, and so on. Today's session, I'm showing you again the work of Refik Anadol. This is a style GAN study of the Gothic, and Refik, I should say, is also going to be involved in the kind of parallel sessions which are going on in the Digital Futures series. Refik will be part of a panel on the 13th of February, looking at the question of AI and creativity. The following day, he said he would join us for a session on AI and neuroscience on this part of this session itself. So these two are kind of interwoven. If the Digital Futures presentations are largely about the work that's been produced under this domain, then these are really largely about trying to develop a kind of an early theory of the digital. As I said, it's kind of, to my mind, it is one of the most promising areas for a theorist, and I find it astonishing. So let's see how they develop. I'd also say that the idea behind these sessions, if this is the first one that you're watching, is that it's not necessarily about a lecture at all. It's more about a kind of provocation, shall we say, and a discussion. I'm delighted to have a number of very interesting practitioners in the world of AI here today. Matthias Del Campo is joining us, Philippe Morel, Manu He, Daniel Bolojan, and so on. And yesterday, in fact, Daniel Bolojan gave an astonishing workshop on cycle GANs and style GANs, which has recently been uploaded onto the same website onto which this will be uploaded. So today I want to look at the question about the history. I'm not a great, well, my background is in history and the work of Alberti, but I think that history is often, we push this history a lot in the architectural curriculum, and we don't think enough about the future by comparison. Having said that, I think that history, the future and the past are inextricably connected. I've always been struck by a title of a lecture given once by Wolf Pricks, Tomorrow, Today Will Be Yesterday. Tomorrow, today will be yesterday. Everything eventually will become part of history. And certainly from my background with Alberti, Alberti was really quite a progressive person at one stage in his life. He's now seen as an historical figure, but he was progressive once. And so we can't overlook history, and history particularly in the context of AI, where you're basing predictions on what has been given in the past on data, shows us how important it is to be aware of what is already out there. So in today's session, the first part, I want to look at the background of the origins of AI, and then look at the future of AI. And in looking at the origins of AI, I want to pick out one particular question which struck me as I was going through my research. And we're in early days of research. There's little out there at the moment. We have a number of books coming out fairly soon. I'm pleased to hear that Matthias Del Campo is working on 2 separate books that are coming out shortly, and hopefully he'll say something about them today. My own book, on which this is based, we decided the title this week, Architecture in the Age of Artificial Intelligence, an introduction to AI for architects. I wouldn't say it's necessarily so introductory because it gets quite theoretical. But now's a chance to maybe test out some of those ideas, some of those observations that I came across. And I mean, it's not meant to be my work, it's someone else's work, but I want to maybe float these out there to generate a discussion. And the theme that I wanted to pick up on to begin with is the notion that that AI is somehow is itself invisible. We're not aware of it, but it's out there. We're surrounded by it. Everything we do in our lives, AI is there, and yet we can't see it. Forget robots. Think about algorithms in order to understand what AI is. So this was a comment I made in the introduction to the book. It is as though the Earth has been invaded by an invisible, super intelligent alien species. And the theme of visibility and invisibility seems to me to be fundamental to thinking about AI, because it's so invisible, there are certain strategies that have been made to try and make it visible, primarily because you need to market it in terms of investment and so on. And that leads to a certain problem, because if you don't know if AI is there or not, you have to find some way of doing that. And it's led to a series of high-profile events in which AI has been promoted on the marketplace, as it were. But this also leads to a problem in the sense that if you don't know if it's there or not, there is a risk that you could possibly be abusing AI and using it as a marketing exercise. So that's essentially what I'm going to do in the first part of this session, is just throw out a few ideas there that we can then have a discussion. Then in the second part, I want to kind of throw out some ideas about what I've picked up on in terms of the way AI is going to be in the future, and how it's going to be perceived in the future. So, and this is not a thorough historical overview. It's just picking out some of the crucial points about the history of AI. And there's much more to be said and to be read about, but let me just simply give you a cursory view of what I found out. And this is a slightly biased British view, I have to say, because many of the characters in today's session are British. I'm sure that in the future, the characters at developing AI will be Chinese, Indian, and from elsewhere, and certainly obviously American. But if you look back at the origins of computation, it's probably Charles Babbage, who was the kind of the polymath who was behind some of the early developments and explored the possibility of not fully realized, but at least conceptually grasped notions of two kind of engines, the analytic engine and the difference engine, which were the kind of early forms of mechanical proto-computers that were at least envisaged, if not actually necessarily constructed. And alongside Babbage, of course, there was Ada Lovelace, who for many years was overlooked, but was the first, now is recognized the first person to start to conceptualize the notion of a programmer. And we'll talk more about her work next week in the question about AI and creativity. But she's now been recognized. Sadie Plant, of course, celebrated in a kind of I saw one of these descriptions about her work as sustained cyber feminist rant, it was described, magnificent rant. Sadie Plant wrote about this, about the women who've been overlooked, but who are absolutely central to the history of computation. And now, of course, Jenny Sabin has just recently completed this installation that involves AI tracking, but it's being called Ada. And for those who are watching Doctor Who, Ada Lovelace has also appeared on a session of Doctor Who. But the person who is, I guess, recognized by most as being responsible for really launching computation was Alan Turing. And again, much of it was kind of foreseen and imagined rather than necessarily seen through. But in 1936, he wrote an article in which he speculated about the possibility of what he called a Turing machine. It was published the following year, and that was really, in many ways, the first of the kind of conceptual understanding of what computation might be. He didn't use necessarily the word computation as such. Turing was at the time a fellow. Was at King's College, Cambridge, the same university as Babbage himself. And of course, during the Second World War, he was responsible for developing the bomb. That's this kind of this machine, again, a kind of proto-computer that was used to decode the Nazi Enigma code, which had an incredible impact on the Second World War. Some people have estimated, well, it's been estimated that from 2 million up to about 20 million lives were saved because of this. And yet the irony of the whole thing was that nobody knew about it because because it was under the Official Secrets Act, and it wasn't until in the 1970s that information about this was launched. So on the one hand, Turing himself was trying to decode, was trying to make visible the invisible. At the same time, his own work was completely invisible. In fact, throughout his life, nobody knew quite what he had contributed. And he was also in 1950, after the war, responsible for conceptualizing the notion of AI, of intelligence. And although he didn't use the term AI because it hasn't been developed yet, he nonetheless speculated about the possibility of there being machines that could learn and that were intelligent. And famously, he devised the notion of what he called the Turing test, whereby you would test out how convincing AI would be by comparing it with a human and seeing if you could dupe somebody who was watching. This was based on a British parlor game called the Imitation Game, where you would take on different roles and pretend that you were another person. The tragedy of Alan Turing, of course, is that he failed his own Turing test in an age when homosexuality was outlawed. He was discovered and convicted. You can see this is the court filings for what he was involved in. He was convicted of lewd acts, homosexuality, because homosexuality in those days was illegal. And he opted for chemical castration instead of going to prison. But nonetheless, this was a very public event. He failed to do, not only was he discovered, but he was discovered and humiliated, as it were, on the national stage. And as a result, possibly of that, certainly a couple of years later, in 1954, Alan Turing died. It's suspected, most people say it was because of suicide, the humiliation of being exposed, as it were. And of course, the irony of all this was that the man who had saved so many millions of lives, that operation contribution was not known, because it wasn't until several years later, in 1970s, that what he did during the war was made known. Of course, we know about him now. The Imitation Game came out a few years ago, and now he's a kind of celebrated figure within the domain of popular culture itself. He's become a kind of poster boy for the gay culture, and also a hero within the world of AI and computation. And of course, his photograph, his portrait appears on the £50 note. He literally is known by almost everyone, and yet during his life, he was unknown. So again, the theme of the visible and the invisible seems to kind of work its way throughout his life. I was brought up in the UK, well, actually elsewhere as well, but one of the kind of dominant figures that was behind my upbringing was Doctor Who on television, of course. And it always struck me that Doctor Who was an interesting character because, unlike the American superheroes who would kind of slug it out in a fist fight, Superman and so on, Doctor Who would never get into a fight. Instead, he would use science and technology to solve the problems of the world every week. And it struck me, of course, that maybe this is what Alan Turing had done. He'd used science and technology to solve the problems of the world. And I was speculating about whether or not Dr. Alan Turing could have been the original model of Doctor Who. And actually, of course, it couldn't have been. He couldn't have been in some way sensitive, because Doctor Who started in the 1960s, whereas the story about Alan Turing didn't come out till the 1970s. Nonetheless, with a Time Lord, you'd wonder whether you should worry about chronological time as such. But at the same time, in many ways, Doctor Who was the absolute opposite of Alan Turing, in the sense that he was somebody who didn't actually do anything at all, but was a television celebrity that was known by everyone. And Alan Turing did something hugely significant, but was unknown by anyone during his life. So this kind of theme is something that I want to kind of just pick out in the way that it's been traced through the history of AI. Another sort of other event that came out that was kind of in terms of the kind of development of AI before the term had even been coined was the work of Pitts and McCulloch, the work on a kind of early form of neural network that was developed back in '43, based on the notion of the Turing machine itself. But the term artificial intelligence itself wasn't coined until 1956, when a group of computer scientists, neuroscientists, and so on, established an event in Dartmouth College in the summer, a kind of workshop, where many of the kind of luminaries of the world of AI, the future world of AI, were gathered. The term itself was coined by John McCarthy here. You can see Marvin Minsky here, and I think that's Claude Shannon here. And it was when it was John McCarthy is famous because he said, well, I had to call it something. So I called it artificial intelligence, and I'd come across the term before, but I could never find out where I'd come across it. In any case, I'm not very happy with it, but that's the term that stuck. So AI is the term that was there. These are the figures, many of whom went on to become luminaries within the field itself. And this is the statement about the proposal for this summer workshop in which the term artificial intelligence is used for the first time. Following that, there was incredible speculation about the possibility of what AI could lead to. It was hyped up incredibly, and it was a lot of expectations were held about what AI could do. And of course, inevitably, with the amount of hype that's was given to something like that, such as AI, you're inevitably going to be disappointed. And the history of AI was kind of marred in some senses by what are referred to as AI winters, when confidence in AI collapsed, mainly because it had been overhyped. And one of the kind of the central issues at the time, we're talking here about the Cold War, was the idea that you could use AI to translate. And of course, now AI is incredibly good at translating. As I'm sure many of you know, I use WeChat, and the translation app is getting better literally by the day, which of course is in the nature of deep learning itself. But at the time, they had lots of problems. These famously, and I recall some of these jokes being made about AI when I was a schoolboy. The translation of the term, the American expression "out of sight, out of mind," it was translated into Russian and back into English again, and came out as an invisible lunatic. The spirit is willing, but the flesh is weak. Came out as the vodka is good, but the meat is rotten. So there were challenges. There were challenges, and the optimism about AI collapsed, and much of the funding collapsed. So they went through what's known as a couple of AI winters. Also, within that, there were other events that were going on. In particular, there was the work of Frank Rosenblatt was highly significant, and he was developing a kind of a model of the mind based on neurons in the brain, the early kind of form of neural network, fairly primitive in some ways, but it was showing a lot of promise. This was part of the connectionist tradition within AI. And of course, there were many different camps, as I mentioned in the first session, different tribes, as they've been referred to, symbolism, connectionism, and so on. And part of the more kind of controversial aspects of what happened in AI was this book that came out with, produced by Marvin Minsky and Seymour Papert, in which they basically trashed connectionism. And as a result of that, connectionism fell out of favor, and symbolism became the simplest approach, became the dominant approach. And that also, to some extent, held up AI, because now we're back into this kind of connectionist logic of neural networks. So what it took basically in this kind of world in which things were kind of, you couldn't see what was going on, AI was kind of invisible. In order to promote it as a kind of a commercial opportunity, there had to be a series of high-profile public events to promote AI. And the first of which happened in 1997, when DeepMind, IBM's computer, took on Garry Kasparov at chess. And many people had speculated about the possibility of AI being good at chess, including Alan Turing himself. And also predictions being made about when it would eventually when it was eventually happened. Ray Kurzweil predicted by the year 2000, and sure enough, in 1997, this happened. This is in the second game, which was over in 19 minutes, I understand. And Garry Kasparov was essentially humiliated. Nobody anticipated that he would be beaten, but he was. And some saw it as a kind of like a triumph for AI, but Kasparov saw it as a triumph for humanity. After all, it was humanity who had actually basically devised AI itself. But he came to the conclusion that eventually AI machines would eventually be able to do better anything that humans could do. Anything that you can do, AI can do better. The second moment in this was, again, IBM clearly trying to promote its own products. They held another challenge. This was when IBM Watson took on Ken Jennings and Brad Rutter at the game of Jeopardy, the general knowledge question, which was significantly more challenging. In both these cases, it could be said that the technology that they were on display had actually been around for some time. It was nothing terribly new, but it was simply the kind of sheer scale of operations that was deployed in this. Anyway, as you can see, IBM Watson won significantly. He beat the two leading champions. And Ken Jennings makes this comment at the end. He scribbles this on his reply here. I, for one, welcome our computer overlords, which is a kind of a tongue-in-cheek reference to The Simpsons. So the whole time there's this kind of popular culture like Doctor Who, The Simpsons, which is playing out, and we're discovering about the possibilities of AI itself. And then famously in 2016, DeepMind, a company in London that has since been acquired by Google, took on Lee Sedol, one of the great Go players in the world from South Korea, at the game of Go. And the game of Go is significantly more challenging than chess. There are more moves in the game of Go than there are atoms in the universe. It makes it extremely challenging. Everybody, of course, expected Lee Sedol to win. And to their horror, he didn't win. And one of the particular moves in the match, which I've mentioned before, but is important because it's one of the most iconic moments, high-profile moments in terms of the game, in terms of AI, was this famous move 37 in game 2, when it seemed that that AlphaGo had made a mistake. There were certain glitches in the system, and there was this move that came across. And initially, commentators such as Fan Hui, some of them thought it was a mistake, and he comments about Lee Sedol that it seemed like a smile was coming over his face. Well, it wasn't long before that smile drained, because this move had never been made before. And they began to realize the sheer strategic brilliance of this particular move, along with a series of other moves that were referred to as slack moves. Slack moves because it wasn't so obvious immediately how strategically brilliant they were, but eventually it became clear. So anyway, as a result of all that, the world of Go was absolutely shocked. A comment after game 2, Lee Sedol, yesterday I was surprised, but today I am speechless. And this, of course, sort of feeds into the whole question about whether AI could be created or not, a question that we will address in our next session. But for sure, it depends, of course, on how you define creativity. But for sure, not only did it prove itself to be creative in a sense, but it also showed humans up. And this goes back to some of the comments in the beginning of the first session about human intelligence. And it seems to me that what AI is establishing is that human intelligence is only, human creativity is only one part of a broader spectrum in terms of intelligent creativity. And it's clear that AI can, certainly in this limited domain of games of chess and Go, can clearly surpass human beings. And of course, this again was a high-profile moment that appeared not only in television, but also there was a documentary that was made about AlphaGo that many of you have seen. I recommend it. It's an extremely good documentary. But what is significant is that this was everybody looks at this and thinks about this incredible game and this incredible move. But in fact, there was another match that was played against the then world champion, someone who was significantly better than Lee Sedol, that was not documented in the same way and therefore was invisible, as it were, to the world of to the public, the world outside. Equally, there was also another version produced by another machine that was produced by DeepMind, AlphaGo Zero, which was significantly better. than AlphaGo, and had the capacity to teach itself, had the capacity, was able to, and I mentioned this before also, was able to play 3.9 million games of Go against itself through reinforcement learning over a period of 3 days, the equivalent of 20 games a second. And this is astonishing in itself. An incredible feat, but because AlphaGo was the one that had the high profile, we know nothing about AlphaGo Zero. I'm sure Wan Yu will confirm that this really was the most astonishing development. AlphaGo Zero was far more significant than AlphaGo itself. So the whole theme about invisibility and visibility, about marketing and so on, is central to the whole domain of AI, in terms of hyping it, in terms of giving it, raising the public expectation about what it's about, whether it's in terms of getting funding from DARPA or other kind of agencies, or whether it's in terms of promoting it in the kind of domain of the stock market. It required these kind of high-profile events to really bring AI to the attention of people around the world. And of course, the interesting thing about this is that it leads it to the potential of being abused within the marketplace. Another significant aspect about this was the fact that this game was being played, was being televised to China. In the West, Go is not such a popular game, but certainly it is certainly in China. It's the kind of national game. And when several million people watched this event and they saw an AI beating one of the best humans at the game of Go, it really became it was a real shock to the whole system. Kai-Fu Lee, who's an interesting character in his own way, he's from Taiwan originally. He came to the States to go and do a PhD in computation, and eventually became head of Google in China, the ill-fated Google initiative in China. So he was in a position to be able to see from both sides. And he wrote this book called AI Superpowers, which really talks about the competition between Silicon Valley and basically China, and Shenzhen in particular, where Wan Yu herself is based. And he makes this comment that not only does he predict that China will actually will eventually prevail in terms of this, but he makes this comment that this was a kind of, for China, was the Sputnik moment. If the launching of Sputnik into space, this Russian satellite that went into orbit, was in a sense a wake-up call for the States and led to the foundation of NASA. I mean, you have to see that basically the space race was itself an extension of the Cold War, was part of the Cold War. And it was this moment when Sputnik went into space that the Americans realized that they were being beaten by the Russians, and that led to what's referred to the Sputnik moment, the kind of holy shit moment. We are being beaten. And so in China, all of a sudden, people became aware of the necessity of AI and the importance of AI. And not only that, of course, also in Korea, where this event was being held, Korea also became aware of this. But 1 year later, President Xi made a kind of a speech about, a bit like in a way, Kennedy's undertaking to go to the moon, largely a result of the competition in the space race. President Xi gave this undertaking that China was going to become a world power at AI. And those of you who've been to China who know how astonishingly popular and successful AI is in China, you can see precisely why this happened. And I should say XCool was founded in 2016, the same year as the AlphaGo match, and just before President Xi had vowed to undertake, to really push ahead with AI. And famously, as I mentioned before, of course, Putin has made this comment, whoever leads at AI rules the world. So there's intense competition that came out as a result of this. But the irony, of course, then, is if AI is invisible and you don't know if it's there or not, there's a risk that it'll be used as a marketing tool. And I mentioned before, Sophia, the humanoid robot, that many working in the world of computation, of robotics, including Rodney Brooks, the Australian-American roboticist, are highly dismissive of Sophia as being simply a kind of marketing ploy. And whenever you see her being promoted, it becomes very clear, being shown, she has been promoted by Hanson Electronics as a form of AI. And although she appears to be appears to be an example of AI with consciousness, of AGI, of artificial general intelligence, of course, Sophia is not, is unable to think. and has been kind of, in some senses, passed off as what she is not. So what happens basically is if AI is not there, there is a real risk that it has been promoted as a marketing tool. And this I would call a form of inverse camouflage. In other words, if camouflage is about concealing what is there, of making what is visible, what is there invisible, then I would say that there's a form of inverse camouflage in operation, whereby very often AI is being celebrated and promoted when it is not there. This practice, this architectural practice, AI Space Factory, for example, I met the CEO at a conference in Shanghai, and I asked him, well, how are they using AI? And he said, well, actually, we're not using, we have aspirations to use it, but we're not using it yet. And in fact, Theodoros Galanos has this theory that wherever you see AI in the name of a practice, it's probably the case that AI is not there at all. So here we have this kind of the challenge where the question about the visibility and the invisibility of AI is made most manifest. It becomes a marketing tool. And in my book, I come up with this comment, which is to say, based on the famous comment from Julius Caesar, the play by William Shakespeare, beware the Ides of March, beware the AI of marketing. AI lends itself to being abused, shall we say, within the domain of the commercial domain of marketing. So I just wanted to kind of stop at this point here and throw it out there as a kind of comment, and to see whether anyone would want to go and pick up on this idea about the visibility and invisibility of AI, the marketing of AI, and also the way in which we have a certain history, which is maybe not necessarily the full history, because that's what's been given to us. The fact that maybe AlphaGo 0 is way more advanced than AlphaGo as well. So I'd like to just, I mean, this is a kind of provocation to get things going. I want to open that up to discussion. I particularly maybe would be interested in whether Theodoros wants to comment on his comment about AI in marketing, and maybe whether Wan Yu would like to say something about the AlphaGo 0 moment.
Hi, Leo.
Wan Yu, hi.
You want me to say something?
Yeah.
Yeah, the AlphaGo 0 moment was very exciting to us, and we somehow heard there's a new thing coming out, because it was not calling AlphaGo 0, it was calling Master. It is a kind of a hidden ID on the Go game. This a kind of BBS that's challenging everyone, and nobody knows what it is or who it is. And it suddenly become very powerful. And eventually, yeah, the DeepMind said, oh, it's our new technology. And it's more powerful than AlphaGo Li, which is the first generation, has the competition in 2016. And then 2017, yeah, the new one came out. Had the fight with Ke, one of the most famous Chinese Go game player, and yeah, he has totally no chance at all, because this generation is so different from the last two generations. The first, the AlphaGo Li, is said to learn all those Go game histories with all the possible strategies, etc. That's the knowledge from the mankind. And the second generation is the kind of prototype of AlphaGo 0, which just need to know the rules, like how to win, what's the rules of a black and white, etc. And it fight with each other. I mean, there's maybe two rows of it, and it fight to each other. And there's a rule to distinguish which one will win in each of the game. And it's called reinforcement learning eventually. And with this kind of new type of deep learning neural networks, yeah, it's become more and more powerful because it somehow reach out or searched for some new possibilities, which are not even appeared in human histories, and we never saw that before. And that is so astonishing because when I learned some of the Go game when I was young, so I kind of understand how it goes. But it's totally out of our thoughts. Oh, we never thought about, okay, how can you do this? Because this is not the regular routine. It's not a routine at all. And you won't do that. I mean, one of those, the moves, you won't do that. But eventually it went. Yeah. Sometimes it looks like a nonsense, but eventually maybe it sees much further steps than we thought. So at that moment, we think, wow, it's really a new generation. It can do something we call creation, because the creation, as we know before, is we show something new, something we never see before. But is it really doesn't exist? Maybe just we don't know it yet. Some of the forms, for instance, some of the OMA forms, let's say, it's not new at all. Some maybe in the sculpture or some Soviet, so historical thing. Anyway, there might be no new things, just we don't know it. And the machine can help us to find out it. I think AlphaGo Zero and the reinforcement learning is something, yeah, in this way. And I just want to make an example about this. Is in our practice in Xcool, we're using a lot of algorithms, not just CNN, but also RNN, also reinforcement learning, etc. We find out there's a really different things came out from all those different models, not just the data you use differently, you can get different results, but also the different algorithms, it will guide to totally different thing. And I think reinforcement learning has quite a huge potential because it's not just based on existing data. Because existing data is very limited. For instance, the CNN, we learn all those modern houses. If you saw the one we did, we called this building does not exist. Those ones we learned a lot of well-designed modern villas, let's say, those little houses. But we do something with reinforcement learning, we might don't need that. We just give the rules. How can we define a good, for instance, modern villa? And then the machine can just do it over and over again. But there's one thing you should do is you make the rule. Sometimes you have to judge which one's better. Yeah. So then people might need to involve in and to make some of the judgments to help. So this kind of data can be accumulated in a larger and larger quantity. Yeah. So I think that's something I want to share. Yeah.
Yeah, just to maybe throw something in there. I mean, Kostas Tasidas has this idea that everything already exists, just simply we haven't necessarily come across it yet. I mean, that's a kind of
right.
a philosophical sort of viewpoint. And I mentioned last time he kind of like he described this. In fact, when we met in Shanghai with Kostas with a plate of biscuits or cookies, and he puts one behind his back and saying, you know, well, it's still there. It's just we haven't come across it yet. It's already there. So. And one could argue that certainly in terms of kind of poetry, all the letters, all the words in the world already exist. It's simply a kind of question of the combination to which you put it to. One question when you're there, just to say, well, I mean, 2016. I mean, you set up Xcool in 2016. How did this play out in terms of the kind of the high profile match itself, and in terms of in terms of China? What impact did it have on you personally and in motivating you to start up your own practice?
Actually, I was always into this kind of new technology and how it combines with architecture. Back to Berlach, like Peter Truman is really into this kind of a new associative design, this kind of thing. But we found there's a big, let's say, a big issue that it cannot cross over There's three things actually. First is the computational power. We set up a traditional machine learning or associative model or design algorithm or algorithm design. It has to run like 3 days with your computer. That's one of the big issue. And second thing is we don't have a new model of the algorithms, let's say. We only have the traditional machine learnings, and that is not so efficient, and the result is not so good. And if you just do like grasshopper, you just do all the possibilities, there's no recommendation system to tell you which one's better. And thirdly, we don't have big data. So in like back to 2010, 2009, we were trying to do a software which we developed for a Korea developer. Anyway, we found out these three things. We cannot cross over it. And we had to give up our thoughts on developing a software for this machine assistant design that doesn't work at that moment. And we're looking for something could resolve these three things. And gradually between 2010 to 2016, we learned there's more new things came out, like the cloud computation on cloud, like computation power on cloud. This is something can resolve the first issue. We can use the cloud server. Yeah, this is first thing. And second is there's new algorithm models came out. Like CNN came out earlier in 2015. There's also already some papers. Also back to 2012, like Fei Li, she was in Stanford and she also launched something, ImageNet, yeah, with neural networks. And then 2016, we all know about DeMine's new work. And then also a big data issue become like more easy to understand after, I don't know, 2014, after all those mobile, these smartphones, yeah, become more regular to everyone. There's a lot of data be created every day. So those three things are the kind of the driving force to make us to make this decision step further with our previous prototype to this next step. Yeah, I think that is something we get from the history. Just because of everything is so coincidence that everybody saw the power of it. But in 2016, but doesn't mean it's just because of 2016. It's because of there's a long history. Also for the history of AI from 1956, right? And then those neural networks has been brought out this idea in 70s, I guess. Yeah, it has been a long while, and it just like doing circles, and sometimes has upside and sometimes downside. Everyone's looking for new solution, but when there's no computational power, when there's no data, there's no new models, it just doesn't work. But the 2016 is just like everything's okay, ready. Yeah.
Let's invite others. Matthias, do you want to say something?
Just a quick comment, because I really completely agree with Wanyu and her view on how this thing started to develop. Specifically, I mean, you showed like the historical development and the famous AI winters that we experienced because there was not much progress being done. But 2015, 2016 was really crucial. Wanyu pointed out CNN. I would also point out that generative adversarial networks came out 2015. Ian Goodfellow actually published his paper 15. So we have experienced it within 5 to 6 years, are extremely fast development because of those couple of papers that came out at the time. But there is one problem which is very architecture specific in that whole environment. And Wanyu actually touched on that too, which is the databases. Because the databases that we're currently working with are not designed for architecture. They're just general databases that we use. The labeling is not what we would do as architects occasionally. So I think what we need to do as a next step is really to band up and create databases that really cater to the architecture industry. I mean, I'm completely convinced that the whole work that is getting currently done in terms of AI and architecture is probably the very first design technique invented in the 21st century for architecture. Like all the other computational design methods that we know, we already designed in the 20th century. They just were refined in the 21st century, but this one is really something different.
Yeah, I want just to add up one thing on this, because there's a very important issue about how to labeling the useful data for architecture fields. We created this XCool platform, and we have over 100,000, like 100,000 users online. They kind of like labeling the usage of our platform, and simultaneously labeling the architectural labels for us. For instance, our machine generate line possible schemes, and then this architect select 3 of it, and then this is 3 possible label, sorry, there's a 3 positive label and 6 negative labels. Just by this kind of move, they download these 3 out from our 9. And this is one way, and there's other ways, like all their moves on our SaaS platform is all be, let's say, recorded in some way without no this privacy offense, but we record the needed data. Yeah, and this data is a very, let's say, treasure, because before there's nothing in this way. Yeah.
Yeah, just to complement to some of both Juan-Louis and Matthias' comments, I think we also have to include the aspect of hardware, not only the software, because neural networks, yes, they are great as algorithms, but they are nothing without the hardware. And I think Jan Goodfellow, he had Jan Goodfellow, who's the creator of GANs, he had an interview with Lex Friedman, and he was talking about this idea of, he was super lucky to create GANs at that period in time, yeah, because if he would have created GANs like a few years later, then probably that GAN, in a way, the solution or the outcome of the GANs will not be credible in a way, yeah, because it will be compared with other kind of larger network that were created like 2-3 years later, yeah. And I think also the success of GANs also depends highly on the computational power, yeah, and NVIDIA doing an amazing job of really developing processing units, yeah, for that.
Just also a quick comment, because that both Vanyu and Daniel, the argument for the powerful machines that can run like these large neural networks is primarily because the neural networks we're working with are so hungry for data. But there is also current developments that are speculating about how to use data scarcity to create neural networks. And that would be super interesting, because then we can really train networks, not because we have millions and millions of images, but because it's more intelligently working through the data. Yeah. So I did this comparison already last time about, a kid that can learn what is a dog just by seeing a couple of dogs. Yeah. And it doesn't need to see millions of dogs to understand that's a dog. And that has to do a lot with the environment it is in. So if you actually are able to create a neural network that has other networks teaching him that's a dog, instead of just trying to learn it on its own, yeah, we might be able to pull off things with less data than we're currently doing, meaning less powerful computers, easier to do, et cetera, et cetera.
Yeah, I just wanted to comment on your initial point, Neil, of I really like this idea of invisibility, and I just wanted I had a couple of thoughts. First, it's obvious that today AI is ever visible, right? It's apparently everywhere, right? And that apparently, I think it's very important to stress, but it is in fact not there most of the time. So and this is not just in architecture, right? It's in a lot of other applications. First of all, most of them, we shouldn't be calling them AI. Some of them are deep learning applications, some are machine learning applications. I believe 80% of the applications are running random forests, right? It's not like AI, but it's something that, let's say, yeah, has taken a name, an umbrella name. And it appears to be at its most visible, I think, like you said, when it's not there. And I think that is an interesting thing to consider. And the other interesting thing to consider is, does the opposite apply? Is it like you mentioned, Putin says, whoever controls the world. Is that control so powerful because it's not visible when it's there? Like, that's my other question. Like, a lot of these technologies, they can be pervasive, right? They have, data issues like, personal information. They have ethical issues, and all this stuff are not really visible to most of us, even though there are people trying to do conversations about them lately, and there is a lot of discussion everywhere in social media, but they're not really visible. So I wonder if the aspect of real power of AI is there because it can be invisible when it works. And I think that there is a bit of impotence in the idea that it's apparently there, but it's not there. And I think that kind of hurts. Like why I have said this and why it matters to me for architecture or design in general is because I feel when we do that, when we say we are there, I have it in my logo or something, but it's not there, we are kind of keeping the field behind. So like when a young architect or a young designer sees, I don't know, a very big company, right? Like we're talking about maybe one of the 5 biggest companies, saying, look, we've done it, we have this AI design. They might think, okay, what do I do now? Like, what's the point? And I think that's the first aspect. Of course, the second aspect is they would never share how they did it, mostly because they don't know how, but also if they knew, they wouldn't. Like, so we have this issue of like, sort of like blocking people that would like to make a difference, I think, through that point. And the last point I want to make about the Listed and also Deep Blue, I think in both cases, it was also a move, right? If I remember correctly, I don't know, in Deep Blue, I believe, there was also a very odd move. I'm not sure if it was a sacrifice or something Deep Blue did that it wasn't correct. And I really want to touch that string. And I think, because in both cases, there was this move, this other move, and we talked about creativity, and, the idea is creativity is something new, and does something new exist? I believe it does exist, and I disagree with that idea, of course, but doesn't matter. But I think that it's interesting to consider that not only I think it's something new, like it wasn't that move that made the difference. It was that move in the context of the whole game and the history and the sequence of moves. So it's something much higher than just a decision. And I think this is something to think of a metaphor or a parallel for design, right? It's not just creating some house that wasn't there. So there is this popularity now lately. Everything is called that does not exist. So there is this anime that does not exist, this thing that doesn't exist, this folk, and this house that does not exist. And that's not the creativity necessarily by itself, but it's also like, what does it generate? What sequences does it illuminate in a way? What does it illuminate in the design space in a sense by just viewing it? So that's my sort of how I see AI being creative in design, not just creating some design that we didn't see before, but somehow like illuminating, okay, what does this design mean? What are the steps to get there? And what are the other designs near it? And what do the relationship between them show us in all this exploration and design intelligence? So I think, yeah, those are the strands that I wanted to pick for a second.
Yeah, and continuing with that idea, it's also, I think, what we call today creative, yesterday we didn't call creative. So, and what we call today creative, tomorrow we are not going to call creative, yeah? And I think it's most of the time, it's also, you have to look at this, not necessarily like they are producing something creative. Maybe sometimes you're looking at, is the process maybe creative, yeah? Is the way that you're chaining certain processes that leads to something creative, yeah? Is this kind of like rules, like in AlphaGo case, those kind of rules that, the way the sequence, how you play the moves and so on, is that the creative part, yeah, not the rule itself, not the move itself, perhaps, yeah. So I think we have to maybe be careful with when we say something is creative, really to understand that creativity can be quite a lot of things, could mean a lot of things, yeah, and could be applied at different levels, yeah. It's not just the precise output of something, yeah.
Guanyu, do you want to say?
Yes, I think there's different levels of like architectural design or creativity. And when we say design something, sometimes we mean draw something, like the form. Sometimes mean the organization, but sometimes it just meaning decision making. So there's a different levels of it. And from our practice here, we are not trying to solve everything. Like the most artistic part is not something we are chasing for. We are more like on the ground trying to solving the most dirty jobs. Let's say you have to draw all the things to represent your idea, and you have to change all those data and or to calculate each room's area and to fit all the forms and do all the regulation check. All those dirty works we think can be somehow assisted by the machine. And this is something very practical. And a lot of our users, our clients, they are really like it this way. The machine can assist them, not just replacing some of their job. So I think we need to figure out what the AI can do to assist the design, not the decision making, of course not, but assist them to analyze the thing, assist them to adjust it easily, and assist them to realize the project easily. For instance, our platform, they can output the final design drawings for the schematic design. Eventually, we will do the detailed design drawings outputs. So for those massive productions, as I mentioned last time to show our work, for those type of work, I think most of the procedures can be done by the machine, but people still has a very important seat there. They have to make decision which direction to go. Yeah.
Matthias?
Yeah, I think that it touches on something which I really, really like about this whole AI in architecture conversation, is that it allows for profoundly different positions to the problem. So it doesn't need to be like, we're not doing the same, which is good. Yeah, I like that. So Wanyu is focusing on a very specific area, and she mentioned that, and I think it's absolutely necessary and important to focus also on that, let's say, tamed problem of the architecture production. But I, for example, from my part, I'm really interested into the wicked problem of architecture production. Like, what does it mean in terms of material culture versus symbolic culture? What does it do in terms of aesthetics? How do humans come into that whole relationship to a machine that provides us with imagery and solutions that we didn't think about, but that inspire us to do things in a different way, architecturally speaking. So there is like an enormous plethora of possibilities to think, like, how does it comply with materialist philosophy? Is it a realist philosophy, and so on? So like, how does it tie into all these things where it's material producing those visual results that we are seeing as humans, and then getting inspired to do something in architecture that is different? Yeah, so that's what I like about this. I can discuss this in the same realm of conversation like Wanyu is, but we have still different positions on what we're working on. And that's for me also progress in terms of architecture. It's not like, a style, like deconstructivist style. They all have to do the same thing, right? And look the same. Wanyu's architecture looks profoundly different than mine, but it still has the same background, technically speaking.
Maybe I could just pick up on that. I think the idea of deconstruction is an interesting thing because it was effectively launched in architecture as a publishing venture by Academy Editions. And it was packaged in a certain sort of way. And one of the things that I guess about the publishing world, which it'd be interesting to get comments of Wanyu and Matthias on this, is that it's always looking for the new. it's always looking for the new. And in fact, you if something's already there, then you haven't got a space in the marketplace. But if you can present it and maybe overhype it as being new, that's when it's kind of becomes a kind of marketing or a publishing opportunity. And one of the things I think is kind of interesting is just the history of Matthias, because Matthias and I are now doing this AD that's going to come out next year, but these things have a long gestation period. And certainly when Matthias first floated the idea of an AD to Neil Spiller about AI, it was like it wasn't even on the horizon of possibilities. And all of a sudden, AI becomes the absolute kind of publishing opportunity, because it's become a kind of a thing that's out there that is novel and therefore potentially marketable as a publishing option. So I find it kind of interesting that right now, I mean, certainly my publishers, Bloomsbury, are very positive about the kind of the selling books, because AI is right out there, especially in China, right? I mean, obviously that's been a huge case. So it's kind of interesting to put that alongside the publishing sort of world as well. Do you want to say something, Matthias, about your experience of getting a publication?
Yeah, that was really interesting, because what you just said is absolutely true. I started sending proposals about an AD on AI about 2 years ago. Yeah, and it was like immediately like no, and like what no, there's nothing there. I mean, what are you gonna try to publish? And then I wrote like this, you saw it, like a really long explanation what's currently happening, like the development of neural networks and how architects are starting to use them, and like this whole cultural debate that comes around it. And it's not just crazy Matthias sitting alone doing that, there's a bunch of people doing that. Yeah. Which, by the way, I just made up because I didn't know there were other people doing that. Yeah, but just to sound a little bit more credible, just told them there's more people out there. And then it took about a year to convince them. And that's also when I banded up with Neil, because coincidentally we started talking about the same things. And I was like, look, I sent the proposal to AD. I think Neil wanted to send a proposal to AD or something like that. And the idea came up just to do it together, just to join forces and get it done. And after a long back and forth and longs of deliberations, we finally got an okay to do it. It's going to be out this fall. I'm not entirely, no, next year.
22, yeah. I mean, part of the problem actually about publishing is the fact that, as you're publishing something, the gestation period is so long. We were just talking about this earlier on with Jess and I. I mean, from my publishing, I've submitted the manuscript. Well, they're still tidying up things right now. In fact, tomorrow has to be the day when everything's delivered. But the point is, it takes until October when it comes out, and by then the whole world would have changed. I mean, I was struck by. I was giving a course at FIU on AI this last semester, and during the course of the semester, the whole nature of the game completely changed. Self-driving cars. Tesla just produced their kind of their update, made it their cars self-driving. So by definition, the publishing world is always behind things. It's always way behind because it can't keep pace with these things.
Maybe to add to this too, throughout the last 2 years, I've been writing a series of papers, and some of them are already published and out there. Some are just to come out now in these months. That helped a lot in shaping and sharpening the argument. And because every one of those papers is peer reviewed, so somebody's going to slap into your face if you're not right, or if you're not describing it correctly. And sometimes you still have to struggle with people who don't understand the environment and just going to slap you anyways. Yeah. I recently had a really interesting, this happens regularly. For example, when I start talking about deep dreaming, hallucinations in papers, I still regularly get slapped by people that say, like, what are you talking about with this, esoterical terms, blah, who don't understand where does this come from, why are we talking about this? And I'm tired to explain it every single time. Yeah, so I just leave it out, which leads to another slapping. But okay, that's just the nature of it. But these whole papers helped a lot in shaping the upcoming books that I'm doing. So the one book is really more about theory and about the cultural implementation, like this whole thing about material culture and symbolic culture and how they both actually negotiate aesthetics, ontology, and epistemology of this whole frame of conversation, which I think is really an interesting problem. And that's going to be one book, and the other book is going to be far more technical. And I'm co-writing that together with Alexa Carlson from Michigan Robotics, just to explain the whole mathematics and everything behind what we're trying to do.
I mean, one of the things I also wanted just to comment on was the discussion we had in the summer. In fact, when you was part of a panel discussion with Daniel Bolojan too, with Hovard Hoekland and Maria Dance of Spacemaker AI, about the, I guess what is interesting about about now, of course, Spacemaker has been sold to Autodesk for $250 million. But what was interesting about the two practices is that actually they depended on getting financial support, on attracting investment. Without that, that would have been absolutely not possible at all. And it's kind of interesting. One of the comments that came up in the conversation, Maria Dad said, she said, well, the word AI does open doors. You use the word AI and it opens kind of the doors to possible investment. But maybe I could just ask you to kind of comment on the whole thing about the role of investment in terms of kind of trying to launch this kind of enterprise such as XCool.
Yeah, it's a very long story, and be honest, at the beginning, it's very difficult because in 2016, nobody understand what we were talking about. It totally has no idea, and AI is already very new to them. And then with architecture, this most creative job, they don't think it's possible. And then we explain, okay, AI is not that kind of mysterious alien. AI is kind of technology, can help us to improve something, help us to release some of the workload, etc. Okay, they slightly to understand, and also they understand the more feasible what is the work of architecture. It's not just about creating. It's about how to representing your idea, how to realize this project in reality. There's a lot of things in between the idea and the real thing. So they think, oh yes, it's really a lot of things to do, and the AI can do help on it. And I think the most important thing to get an investment is you have to tell your story very clearly, how this AI can help this industry to get to a new level. So this is something from my experience. They have to understand. So there's a long way to educate the market. Even for the CV markets, you have to make all those investors understand this is a really good way of investment to the future technologies. Yeah.
So the question that I have for you is, I mean, just tracking the kind of the story that Matthias has been telling, and I've also experienced this. To begin with, no one was kind of willing to kind of publish, or in your case, invest. But then all of a sudden, it becomes a hot topic. It has, just in terms of the last 4 years, how to what extent has AI become now a marketing tool? I mean, a way to attract investment, whereas before it was something that was very difficult to find investors for.
Yes, today everyone understands what AI can do. It is a kind of a technology can help us to be faster and more efficient, and even the analyzing of this decision making is with more rational, let's say rational improvements, let's say. So there's some cases approved our methodology, and our AI can really help on the real cases. And let me make an example. Vanke, maybe some of you know, is one of the Chinese largest real estate developer. They had a project with the land master planning or layouting with different type of buildings, or let's say different units they could sell. And in their previous scheme, there's let's say 0.3 billion overall value of their scheme. This is something they already had, and they're not happy with it because they think it can be higher. But because of regulation constraints, all those different code, and also the FAR, GFA, etc., all those constraints, they cannot find out what is the best solution to get higher value. But with our platform, with the XCO platform, it can easily find that there's extra possibilities. So there's not just 0.3 billion, there's 0.45 billion possibilities. And this scheme is something they never saw it before. And when we present this scheme to them and prove this is feasible with all the regulations, all the parameter requirements, etc., they find out, wow, it is really a good solution. This is something maybe in some limited time, in a short period, the architects, traditional ones, they cannot achieve with. And the machine proves itself, it has the value to create more value, not just to be faster, to make things easier. It can create new things. This thing is not a creativity, but in a way, it reveals something they never thought about before. Because it has this large, very huge, powerful computational power, so it can find out a lot of possible things, and it can recommend which one is better for this solution. Of course, there's a lot of things you need to do behind, all the data analyzing, all the algorithms, and also people need to involve into each steps decision making. But eventually, we get these results, and this is just one of the cases. There's more cases to help them to get better ideas and to get more possibilities. They can make decisions based on broader view of the possible schemes. So this is something be proved, and then our investor buying this story. It's not just a bullshit, AI can do something fancy. No, it can help the production, can help the developers to get much higher value. Yeah.
Just to complement something to what Wan Yu is saying, I don't know if how many of you saw, there was at one point an article in Austrian press about like something like 30% of the startups in Austria that were claiming that they are using AI, they were actually not using AI. And then, then it's also this kind of discussion like, you just use the AI for the sake of using AI. And I know that I had at one point a discussion with a friend of mine. I don't know how many of you heard of typing DNA. It's typing biometrics for authentication. I was showing him a sort of idea, and I was just presenting to him a concern that I don't want to come across as I'm just using AI for the sake of using AI. And he was saying, as long as you're addressing a problem and that problem can be solved only with AI, then no one will have a problem. No investor or no other person will have a problem. And I think also this is what Yang is saying also, is like, it's not about necessarily that, yeah, I'm just using AI. If you prove in a way that there is a clear application of that AI, why that technology makes sense in applying it in architecture, then it's great, yeah. So I think here, just to connect further with architecture from here, I think also for us, it's extremely important, like as architects, I understand that we have this kind of, not myth, but this kind of way of operating as architects. We just play with technology because we just want to explore and whatever, yeah. But I think we have to also look at what exactly we are solving, what exactly we are trying to solve, yeah. If Matthias is looking at design, Wan Yu is looking at other things that are more pragmatic, another architect is looking at other domains in architecture that are more addressing other levels, I think that will help the overall profession more than just us fooling around with AI, and then being proud that we are working with AI, yeah. So I think this is also that part of, marketing. I understand that the world works on PR. Yeah, the entire world works on PR. You cannot live without PR. But I think if we want to have progress in architecture, I think we have to be a bit more mature, and really, if we use AI, then we should look at specific problems. And then we don't apply AI just because we want to apply AI, but we apply it because that's the logical, in a way, logical, in a way, a logical solution for that problem that we are trying to solve. Yeah. And I think if we have that kind of approach, then for sure, we will end up with a lot of progress. Yeah. A lot of progress that actually you can set it in stone. Yeah. It's not just this kind of like, just marketing, PR, something that sounds good. And then when you look behind, actually, there was no AI involved. Yeah.
I wonder if there are any other questions that anyone has, because the second point I wanted to bring in soon. Do you have any further questions from the group, from people who haven't spoken yet?
So I see that here somebody's asking, does the profession have that type of resource for researchers? So I think right now in the world that we live in, I don't think we have that kind of excuse, because there is access to like a lot of open source access to networks. Of course, maybe they are not the most advanced ones, but at least it's an entry level where you can start to get involved with this. And then you also have a lot of cloud, in a way, options to train the models and to play with this kind of AIs. So I don't think resources is a problem. Yeah, especially in today's age. Yeah.
There's a comment just what Sarah made in the chat that without military funding, it wouldn't be at this stage. I think that's absolutely true. If you go back to this question, it was initially, Alan Turing was working for the military, and then a lot of the work that was kind of done from the 50s, 60s onwards was funded by DARPA. It's absolutely crucial, and the whole thing was fueled by trying to understand what the Russians were saying, kind of thing. Yeah.
Maybe to that end, one thing, I just posted a link in the chat. This is sort of a preview for you guys because it's going officially tomorrow online, which is the page for the Architecture and Artificial Intelligence Laboratory at the University of Michigan, which I just founded together with a couple of other people. So the main idea behind it, to make it official and make it something that is more rooted in an institution, is of course to facilitate funding opportunities for that. Once you have a laboratory, you can actually write that in a funding proposal, send it out. And the main goal of this is to create a couple of postdoc and doc positions that are focusing on the research of architecture and artificial intelligence, in collaboration with Michigan Robotics and Computer Science. So it's really an interdisciplinary laboratory. The idea also being that it's not just architecture PhDs in there, but also PhDs for computer science and robotics. So they can, exchange ideas and techniques and so on. So this is really a test now. It is supported by the Dean of Taubman College, Jonathan Macy. So he said that's a great thing to do. And that's the issue with research, is that you have to get the research funds to do serious research, because without the funds, you can tinker around with software, you can tinker around a little bit with like hobbyist level of coding, but if you really want to go into the depth of it, you need to institutionalize it.
I just would say that to that I think that in a sense the crucial domain that we're talking about is education, because we are, all of us involved here with teaching, and I think the point is that we're trying to prepare a generation of students for a world in which AI is going to have a huge impact not so far into the future. And I think that's an important point. I mean, certainly in terms of FIU, I know that by the end of the decade, they're going to be teaching AI in every single discipline. It's not as though it's kind of like something out there. And my point is that we actually have an obligation to try and alert, shall we say, the students of today to this whole sort of world, because it is going to it's going to be part of our students today are going to be at the peak of their career when precisely the singularity and all these things that are being predicted are about they're going to be there. So we absolutely have an obligation about that. I wanted to move on to go and talk about the future of AI. Do we have any further comments on this before we move on? Okay, let me just kind of make throw in something else to his way of kind of provoking the discussion a bit further. So, I mean, the future of AI, which of course is something one can only speculate about, but nonetheless, in many ways, I think it's really important to be able to kind of get that out on the horizon to make it a part of the agenda. prediction is very difficult, especially about the future. One of the things I've discovered, I don't know if you guys have discovered this or not, but the problem about prediction or about bringing something out new is that if it's wrong, it's obvious it's wrong, and if it's right, it soon gets kind of absorbed. I had this experience back in Cambridge where I lived next door to a guy called Clive Sinclair, who was responsible for introducing or spending a lot of money on launching a thing called the C5, which is some kind of electric sort of tricycle that you'd lie down on. And it was a huge flop. He was a guy who actually had invented the pocket calculator, but hadn't invested in it properly and made a mistake there. But he made a second mistake investing in something that wasn't going to work. And it was a huge embarrassment to him. Meanwhile, I back in 1990, what was it, 1, 2 or something like that? I think it was. I redesigned I bought a house and redesigned it, and I put in a stainless steel kitchen. Now, what was kind of weird was those days the only people putting in stainless steel kitchens were a few architects and Her Majesty's prisons. They used stainless steel for prisons. And in fact, I had to go to a company called Anderson's who were fabricating stainless steel for prisons to get my counter fabricated. And of course, for a while, this was for about 6 months, this was new. And then all of a sudden, stainless steel kitchens became kind of popular, and someone said to me, "Oh, a few years later, oh, you've got one of those kitchens." And I wanted to say, well, I was one of the first people to do it. But the point is that once you do something that's obvious, it becomes it's right. It becomes obvious. If you do something that's wrong, it's equally obvious that it's wrong. But anyway, just to kind of comment on this, I mean, Ray Kurzweil is possibly the person who is most famous for making predictions about the future. Kurzweil's view is basically is that the reason why we have a brain is in order to make predictions. I mean, he uses the example of a kind of primitive cave person who is kind of walking out and is heading in one direction. Then they see a kind of dinosaur or something coming across the horizon and realize that that's going to intercept its pathway and therefore decide to go and take a different sort of route. So the prediction is fundamental to survival in many ways. And of course, so humans are based on that. And of course, typically computers too. Prediction is an essential part of AI. And one of the comments we'll come to when we deal with neuroscience is that the idea of prediction itself is perception itself is inherently predictive. This is a comment that's coming out in neuroscience. People like Anil Seth are talking about this kind of question. So the idea of prediction is kind of central. And Ray Kurzweil has been the kind of now he's I mean, going just to pick up on the comment we were talking about before about visibility. He's now working for Google. This is actually a building that's about 100 meters away from where I am right now. It's the Google headquarters in Venice, California, designed by Frank Gehry with these binoculars, which is kind of interesting in itself because it's about searching, of course, Google. But then the other aspect of Google is, to my mind, I don't know, I'm sure someone's commented on this. It's not so much about you searching for a product as actually you becoming a product that they're searching for, in the sense of they can pick up on your searches and so on. And it's precisely the advertising that itself is kind of funding Google. So we might think it's about searching, but it's ultimately about advertising itself. Anyway, Ray Kurzweil is now part of the Google initiative, but he's over the years has been making a series of astonishing predictions. Initially, according to Moore's law, but more recently, according to his law of diminishing returns, whereby he has a series of publications. And over the years, I guess what's interesting about Ray Kurzweil is that he's made, from the age of intelligent machines, he's made a series of kind of insightful sort of predictions, all of which have come true. And all of which in some ways seem a kind of rather lame now because they've been so obviously true. But 86%, according to his estimate, 86% of his predictions have been correct. Sometimes he's been a bit optimistic in terms of the implementation within the marketplace, but some of the ideas have been actually have eventually been marketed. But anyway, so along the over the time, this is, I think, it was an interesting one back in 1992. And the point is that, going back to my stainless steel kitchen thing, in many ways, it's kind of what he says is absolutely obvious now. You know, this idea that somehow you would be able to log on into the internet and be able to have access to all the information all over the world, with a kind of something coming out of their school bags, out of their satchels, a kind of laptop and things. You know, of course, people say, but actually in 1992, this was absolutely not obvious. And it's actually, it's a genius of Kurzweil that he's able to make these kind of comments. And there's a series of other ones. I mean, some of these are kind of in a way too obvious now. But again, it was a fact that cables are disappearing. I mean, now, of course, it's true. But anyway, so Kurzweil has done a series of different things which have been very interesting in themselves, and he's proved to be extremely prescient in being able to sort of grasp what the issues are and largely correct. By comparison, there was this guy, this Toby Walsh is also, he's interesting in himself. I disagree with the title in the sense I don't think machines can think, but nonetheless, he comes up with a series of predictions which actually are kind of like, I mean, they're obvious in some ways. Some of these things are kind of like, it's almost absurd. I mean, you talk to your rooms. Well, you know, we already talked to Alexa, and we already, I mean, but Azrai's already done an installation back in 2013 where you could use, we use Kinect to detect a voice and a wall could respond to that and so on. So many of these things are blindingly obvious, and he's predicting this for 2050, but these things are themselves already here in some ways. The idea number 10, we live on after our death, is interesting in itself because just this last week, there was this kind of, someone was proposing that we could have a kind of avatar which can kind of be based on our data and continue being who we are. And of course, we were talking about Zaha Hadid and how her practice carries on, and one could potentially generate sort of Zaha building designs after her death. But it was the first one that you will be banned from driving, in a sense, which is, I thought, the most interesting comment that was made in some way. And the logic behind Toby Walsh's prediction about driving, and it's something also that Elon Musk has mentioned as well, the idea that we're no longer allowed to drive. And the way that it goes with Toby Walsh's thing is to say, well, what's going to happen is that as self-driving cars become more and more present, we are going to use them more. I mean, I could imagine especially something like Uber, because in a way, you don't really interact with the driver very much in Uber. Well, you can, you don't have to. It's almost like you don't really have to have the driver. So I can imagine that very soon Uber cars will be all self-driving cars. So the idea is gradually we'll become more and more using self-driving cars. And as a result, we will start losing our skills as drivers. And then, according to Walsh's argument, basically, then it becomes more expensive to drive your self-driving car. And eventually the insurance premiums will go up and we will just stop driving. But the important point I think that Walsh makes, which I think is a really fascinating kind of comment, despite the lameness of these predictions, what he says is basically, and we won't notice or care. Now that's an interesting kind of comment. We won't notice or care. I mean, one of the things I think about our contemporary culture is that in some ways, this is a comment that's been made by a guy called Andreas Huyssen in his book, Twilight Memories, is that we live in a culture of amnesia. We almost forget the past. We continually forget the past. And I would invite you all to think, well, what was it like when we didn't have cell phones and we didn't have wireless internet and so on? I mean, it's almost impossible to even conceive of that sort of time. It just seems so foreign. It's not really part of our world today. So I think one of the interesting kind of comments is the fact that these things are incremental and we won't notice or care. They creep up on us in a sense. I mean, this whole thing about the self-driving car, the comment many people have made, it's not as though it's a sudden revolution. You suddenly have the self-driving car. No, what's clearly happened with Tesla is you get these software updates gradually, until you reach a point that happened, I think, in October, when we kind of reach this moment when the self-driving car is a reality. In many ways, I think that even though it's a kind of an aside in a sense, is a really interesting sort of comment to be made about Ray Kurzweil's sort of commentaries in some ways. The idea that somehow these things are going to be very incremental. The other comment I want to make is basically that when we talk about AI versus humans, as we have over the last few weeks, is in a way, it's in certain specific domains, such as Go or chess or those kind of logical operations that AI is clearly much better at certain things. It's good at sort of simple rational operations and not so good at others. So in other words, I think that it's very difficult to necessarily pinpoint any particular moment in time when something's going to happen like AGI. I mean, how do you define it in sense? Because there's so many different sort of things happening all at once, different sort of rates of operation. It's almost impossible to do that. But the singularity is near is one of the comments that Ray Kurzweil makes in predicting the singularity. So, I mean, just to kind of give an overview of and I haven't put any dates on this because they're so controversial, but the kind of stages that have been commented on by various commentators about AI, there are different sort of levels of AI achievements. The first one being when AI matches human intelligence. And in a way, we're kind of partially there already, right? I mean, in certain areas it does, and certain areas it doesn't. Then the next point is the moment called the singularity, which is the term is described by Kurzweil as being a bit like an explosion of knowledge. You know, once you get this kind of exponential increase in intelligence, then it leads to other intelligence and so on, and we get this explosion of knowledge. And then shortly after that, we have this sort of moment, AGI, when AI gains consciousness and so on. And then there's this other, these other terms have been used, superintelligence by Nick Bostrom, who's a bit skeptical in some ways about always warns us against what's going to happen with superintelligence. And then so similar to that is a term called ultra-intelligence, which is coined back in the 60s by Good. And what was interesting about that is the idea that somehow that at a certain moment, machines will be able to kind of invent other machines, and that's the final invention that we will ever make is that, because after that we will be left behind. But one of the comments I wanted to make is about this is and certainly when I've been surveying the literature, what I've discovered is that there is complete confusion about what these terms are. I mean, so some of the authorities even have been kind of collapsing the singularity into AI meets human intelligence, almost like they're the same thing. And other people have kind of have made the mistake of calling the singularity the same as AGI. They're not the same, but nonetheless there is this kind of confusion. And then if you look at some of the predictions about when we're going to reach these periods, there's absolutely no consensus. There is a huge range. I mean, especially with AGI, Rodney Brooks doesn't think it's going to happen until 2099 if it happens at all, whereas Kurzweil is far more optimistic about it. But I guess my point would be this: is looking back on the kind of self-driving car model, that's the point. Is can you even have any moment in time where there is a kind of, you could demarcate this when there are so many different kind of parameters that need to be considered, and this tendency to want to predict these things in advance is clearly a kind of a problematic enterprise. And will we even notice it? Will we even notice when the singularity happens? I mean, if it does happen, you know, and it's. So I think this kind of, you can take this comment about Walsh and apply it to all these things, and will we be able to notice these things? It will happen, and we won't even notice or care, and then suddenly game over. This is the comment that was kind of put about the ultra intelligence. Once the point when AI starts developing other AIs, then that's when human beings potentially the game will be over. So I just want to kind of finish on a kind of a few sort of thoughts about. And then we'll have a discussion about what we're going to call AI in the future. And it might seem a strange thing to say, but in some ways, I think it is kind of interesting to sort of think about and reflect upon the various sort of models that we've had in the past and how our definitions of terms have changed. Because of the kind of, let's say, the threshold of use of certain sort of terms, suddenly we change the terminology that we use. So this is an example of although one of the first cars, and the term that was used, I think, is a beautiful term, horseless carriage, because everything was a horse and carriage up till then. That was called a carriage. Then we get to a certain sort of point when a carriage without a horse is invented, you call it the horseless carriage. But once you meet the threshold point where there are more horseless carriages than carriages, you start calling them cars, and then you start calling carriages horse-drawn carriages. And the similar thing we can think about in architectural culture in terms of drawings. In the early days of CAD, there were CAD offices and there were other offices where they didn't use CAD. And a drawing in those days, you would say a computer drawing. And a drawing was a human-drawn drawing. And then after a certain sort of point, you reach the kind of threshold whereby there are more people working on a computer, and a drawing is simply a computer drawing, and you actually have to specify a hand drawing. So you meet these kind of different sort of thresholds when you start changing the kind of terminology in how you're operating. And I guess this would probably be the same in terms of the way that we use self-driving cars, in that for the moment we call them self-driving cars, and we call cars, cars. But with time, eventually a car will be a self-driving car, and we will probably have to specify a human-driven car. It'll probably be some kind of romantic thing, just as you're taken to a wedding these days in a horse-drawn carriage. You might be driven to a wedding in a human-driven car. So the whole sort of kind of terminology begins to shift and change as usage changes. And so the question that I would sort of put up there is how will we refer to artificial intelligence in the future? And we've already kind of commented that maybe human level intelligence is not the absolute level or the limit of intelligence. We're getting forms of intelligence that we can't even conceive of because they are like the slack moves in Go. They are beyond our comprehension. But nonetheless, there is a kind of form of intelligence that's appearing out there. So just to briefly sort of mention about the question about AGI, a lot of people are kind of investing in this idea about when will AI get consciousness. I mean, there are a number of kind of comments that have been made about this in way that that maybe we don't. I mean, the idea is that somehow that once you get enough computational power, you will reach consciousness. I'm not so sure that necessarily you need to align consciousness with computational intelligence, and certainly that's the view that Dennis Sabis has, and likewise Anil Seth, that maybe there are two different things. They're two different orders of things. And what I would also say, these guys are interesting in themselves in the sense that they have, Dennis Sabis, I think, did a PhD in neuroscience and became an AI expert. Anil Seth was the opposite. He did a PhD in AI and became a neuroscience expert. And in some ways, what you can begin to sort of see is that actually the question about consciousness is not so important. Max Tegmark goes on to say, well, actually, eventually, that's the only thing we can cling on to is maybe consciousness, and we should redefine ourselves instead of Homo sapiens as Homo sentiens, because we'll be outclassed by computers. And then Elon Musk makes a comment that maybe we're already superhuman because we have these extensions of our capacities, capabilities. But the question then becomes, once AI is kind of so prevalent, will we still call it AI? And it's kind of like the comment Toby Walsh makes is maybe the term artificial doesn't help at all. And what was interesting, I think, was the initial term going back to this conference back in Dartmouth in 56, I think it was, when John McCarthy coined the term artificial intelligence. He wasn't happy with it. He wasn't happy with it because, he had to call it something, so he called it that, but, it wasn't necessarily intelligent. Maybe artificial, maybe what we're talking about is not artificial intelligence, but simply intelligence itself. Jeffrey Hinton is another person who has a background. He did a PhD in neuroscience and then became a very famous AI expert now based in Toronto. And he just simply says, I want to know how the brain worked. And likewise, Demis Hassabis, who is behind DeepMind in London, he doesn't use the term artificial. He doesn't use the term artificial intelligence. Our ambition at DeepMind is to build intelligent systems. So my speculation is that maybe in the future we won't be talking about artificial intelligence, but just simply intelligence. this, in fact, was the kind of one of the conclusions I came to in my book, was that the quest for AI is the quest for intelligence itself. People are not talking about artificial anything. It's about intelligence, and that's why you get neuroscientists and AI experts essentially looking at the same kind of question. So my point would be that we talk now about architectural intelligence as though that is a kind of special domain. And eventually, when everything becomes intelligent, you'll just call it architecture. When everything becomes, an AI itself is a term that I suspect will disappear. So I just wanted to kind of throw that out there as a kind of a thought that what will happen in the future? Will we ever have these kind of moments of the singularity? Will we be able to even conceive these things? Or are they, as Rodney Brooks say, kind of empty speculations that happen in academia but are kind of meaningless in themselves? Comments? I mean, is the term artificial useful in AI? That would be the kind of question.
Maybe can I share my thoughts on that? Yeah. So sorry about my camera. I think it's really true that nowadays we don't really need to memorize any phone numbers because we have smartphones. I think it is really true that these kind of technologies will be just given. People will lose the ability of driving cars, lose the ability of a lot of many things that are referred as dirty jobs. And I think it is really important that we kind of define or start to realize what should be our role as human, and kind of really understand the distinction of different types of tasks that only human can do or human does better, and what machines or these kind of intelligence can do better. These will become tools that will be very helpful for our lives, but they won't, I don't think they will replace our humans. And I feel like a lot of these discussions about AI is really kind of eliminating the humanness of like anything behind it. For example, the AlphaGo on the scene, of course, we only see the big screen of AlphaGo, but behind the scene, there is a huge team of people and huge sets of machines are analyzing and calculating and making a lot of different decisions behind the scene. And I think it was a teamwork of human and machine. And there was team of humans were deciding which algorithm to go for, which algorithm to play, or where to place the computers, and how many server powers they are going to use, and so on and so forth. And I think there are so many things that are still needed done by human. And I think it's really important that we realize and understand that there has to be a collaboration between human minds and these tools. And I'm also really interested in discussing about those aspects in architectural field. And I mean, that's why one of the things I have been working on with the augmented reality is one of that kind of sense that that we are dealing with a lot of like really highly manual work, but that is very much done with the use of human kind of intelligence or kind of intuition that can adapt to different kind of mistakes or errors in real time. But also there are so many things that are coming from computer that humans cannot really do by kind of manual sketches or just like kind of traditional ways of imagining the geometry. So I think there are lots of ways to kind of deal with the kind of teamwork or collaboration between these two kind of really distinct intelligence. And I'm really curious how other people also think about this human roles in the future that is playing here.
Maybe
Go ahead, Matthias.
Just sorry, I didn't want to interrupt you, but just to your point about the question whether to call it artificial intelligence at all. I think, who was that? Somebody did that. Theodore. I think Theodoros made this comment before about AI, like AI is basically an umbrella term, right? And so it's actually describing like a whole set of different techniques that are getting proliferated at the moment, which is based on a variety of different neural networks. And I'm pretty sure we have not discovered all the possible things we can do in this kind of area. So there's still room to grow. The term is useful, I think, in terms of differentiating very simply between organic intelligence and artificial intelligence. So it's if we as humans possess organic intelligence in a variety of different ways, then we can differentiate that to something that is synthetically created or achieved by just calling it what it is, artificial intelligence. Yeah. The bigger question is if it is intelligence at all. That's the point I think that really is an interesting discussion point, because there's like a dozen different definitions about what intelligence actually is. Yeah. So there's like very simple ones which come from medicine, there's others that come from anthropology, there's others that come from computer science, neuroscience, and so on. So there's like different ways to describe intelligence. And I don't think we are really at the point to specifically define what all these neural networks entail. They're basically imitating, and we discussed this the last time, they're imitating processes of the human mind that we think we understand in a basic level. We don't understand it completely, but we have a specific understanding of that. And as soon as we have better understanding of that, also the neural networks, the artificial neural networks, will increase in their capabilities because we just understand the process of thinking better. But to the point of how to use artificial intelligence, I mean, there's like two areas that are really interesting to discuss. You remember Mark Burry, he pointed out that artificial intelligence might be nothing else than an extension of the mind of the architect, right? It's like a tool. Like every tool, it's an extension of our body in some way or the other. Yeah. Artificial intelligence as being a more sophisticated tool that we can use to achieve specific goals. One is trying to achieve automation in specific processes of architecture. I'm trying to interrogate it in terms of its artistic and ethical values and so on. So there's different ways to skin a cat. But in a larger extent, the whole conversation is actually part of the conversation on automation in the world. Where we are going to have there's like a lot of things we have to discuss along that line, specifically economy, ethics, ecology, and so on. So which are really larger aspects here of how we're going to live our lives and how architecture will cater to that life in the future. That's very important. Yeah, like how are we going to be a part of an automated world without work, where economical systems are going to emerge that are different to what we're seeing now. We're already talking about the post-capitalist era, right? Mark Fisher has wonderful writings about that idea that, how are we living in a world that is where we are inundated by technology, where work is different than what was thought of in the capitalist era of the 19th century. We're basically working economically on a system that is 100 years behind our technological abilities, which is kind of bizarre to say the least, but we're holding on it because it produces money in some way or the other. Yeah. Sorry to go for this really large picture, but I think that's important to understand that what we're discussing here has larger repercussions.
Yeah, no, just so we pick up on that, I think Alexa makes a really valid point. All the terminology we're using, I mean, learning, do we mean the same when we're talking about AI and we're talking about human learning? I think the term intelligence and so on, we bandy around the same term, but actually they become different in their different sort of contexts. Just to pick up on Samin's point, that's something we haven't, I was meaning to address in the first session. I didn't get around to doing it, but I think it's important to kind of, to my mind, the comments that were made by David Chalmers and Andy Clark in the Extended Mind essay back in the 1990s, where it was, there's a kind of genealogy you can see that concept. But the idea that somehow the cell phone is kind of becomes part of us because that's where we put our, we don't memorize numbers anymore. They're all memorized on that. I think you can sort of construct a kind of genealogy between that then you get then there are other people who kind of who pick up on the notion of the cyborg and so on and so on and so on, and eventually we get to the point where we're now at, which is basically extended intelligence, whereby we're using the AI as a kind of prosthetic extension of the self. But one of the comments that was made about that in some ways was that rather than seeing as competition, it's kind of a question of how you can supplement the human with these technologies. But one of the comments was made is that maybe it allows us to become even more human because it cuts out all of these kind of things that we're not very good at, frankly, which is the kind of mechanical processes and things, and allows us to invest more time in that, which I think is a very kind of valid point in itself. But one of the comments I want to make is that, you know, I mean, this thing, going back to this kind of question about the imperceptible change, how things do change and maybe you don't even notice it or even care. I mean, I've always made this kind of comment that we've even in my, since I was a student, things have died out. You know, the travel agent is not really, you will book online. The idea of kind of camera shops have pretty much died out because you have cell phones and the idea of kind of getting your films processed. There's no film process. Well, maybe there are processing places anymore. Things happen and gradually, imperceptibly, they change, and maybe we're not even aware of it. And I was just wondering, I think this is something we're going to look at later in the final session, really, about what the impact of this is all on architecture. But if you were to take the model of the self-driving car and push it to its extremity, you know, if you don't need a driver anymore because there's a car that will take you somewhere, and once you reach the point where, and I'm sure it's going to happen, where AI will be able to or whatever we call these systems, will be able to generate buildings, will we ever need an architect? Anyway, I don't want to go, that's probably going to be a discussion that was going to take place in the future, but I think all these are kind of valid considerations. Anyway, let me open up to other comments.
I remember, sorry. Okay, I just remember there's one metaphor made by Fei Li. She once said nowadays AI is like you have a million of 3-year children, and they can do a lot of things for you. So, you know, each of the AI cannot do a lot of things, but there's a lot of 3 years of kids. They can repeatedly do a lot of things, and they have some level of intelligence already, or the smartness. Yeah, so it's a very interesting way to do this, to think about what is the artificial of intelligence. I think this is a very interesting metaphor. And in one of the scientific sci-fi, let's say sci-fi novel by a Chinese writer, Cixin Liu, The Dark Forest, and he also made an AI kind of imitation in his book that like also million of people, one people just doing one thing as showing the black or white flag. And there's a large matrix of people on the plaza, and they just do this, do white or black. And this entire thing is the original machine of AI. So this is something very interesting. Yeah, get from the something I just get in mind. But the interesting metaphor.
I mean, so it was, you mean a three-year-old kid? Is that what you meant with Fei Li?
Yeah, a million population of the 3-year kids.
Yeah, maybe I can. I believe this thought is beautiful in a lot of ways. I mean, I hope you can let me be part of the conversation. I'm totally an outsider in a way, but I'm still a curious person. And my background is in history of architecture in a way, so maybe I can jump in some things that were mentioned today. But of course, I believe that with your comment, I cannot stop thinking that we need like a new kind of sensibility, or at least we are experimenting a new kind of sensibility. But there is a lot of resistance because we have a history. And there is an important thing in this, because in a way, the idea of the artificial, it's related with our history, of our preconceptions about things. And this is in part why I reject, not only me, a lot of theoreticians, philosophers that I read, that they reject the idea of the this binaries concept, because in a way, what we are teaching, if we are teaching to the computer, is to think like us, and that could be a problem, because in a way, I'm afraid that it can overcoding the structure and make it even infinite, like monotonous tracing of stage that we are repeating and repeating continuously. And that's the problem. And this question that Neil is super controversial about the kind of continuity between the history and the future, and this discussion, or the past and the future, and this discussion between history and creativity, it's super controversial in a lot of ways, because I mean, I'm afraid that in this phrase that you say, we continue forgetting the past. No, the problem is that we continue forget questioning the past. We are not questioning our past, and maybe the problem is that we cannot escape from this past, from all this preconception that we have. And this is the problem with prediction as well, that we believe that we can pre-trace, in a way, the destiny. And, and that can be a little bit, I mean, it's my concern that this can be, in a way, this put us as the center of everything again. And this could be a problem, because in that way, we are like going to a kind of, yes, pre-trace future, or this idea that we can change everything, but it's not, I mean, we shouldn't go in that way. I believe that it's the same with the idea of control and the architect. The architect should control, the future should control this idea of projection. So in a way, you know where is next. And if we know what is next, why are we going to leave it in a way? No, what about experience, and what about sensibility? That could be my question.
Can I just, well, you just triggered off something I meant to say, which my apologies for not mentioning, is last week, Philippe Morel came up with this incredible sort of comment, and it only hit me afterwards. So my apologies, Philippe, but it was and he was talking about Le Corbusier and about how we, and this is really, really, really interesting, how we need consciousness to even have architecture. In other words, you can take a drone flying around with a LiDAR, and you can record the three-dimensional, you could describe an interior of a building. But without consciousness, we absolutely are not aware of the qualities that are appreciating it. So my apologies, Philippe, I think that was the most profound statement, and we didn't pick it up, but it was, and that's why I think consciousness is so important. We wouldn't even have architecture if we didn't have consciousness. Absolutely, totally profound.
Maybe to Marina's point, thanks a lot. Actually, this is absolutely true. So that is a great comment, Philippe, and now also Neil. Marina, about your point in terms of, let me talk a little bit about the role of history. And I'm particularly just being completely egoistic here with my work on that. So it's my point of view. It doesn't mean that it's everyone's point of view. And I've been also criticized for that. But I actually made the example, or the point, basically, that architects work like data miners. When you're getting educated in architecture school, you have a discriminator, which is your teacher, your professor, that is teaching you, for example, different architecture styles in history. So he's going to teach you what is Gothic, what is Baroque, what is Romanesque, and so on. Yeah. And how is he doing that? In a lecture, he's showing you images. Yeah. So he shows you images of Baroque architecture, of Gothic architecture. And then after a while, you as a student are going to be able to differentiate between those styles, because the one discriminator, let's say Neil, showed you images of, Renaissance architecture or something like that, okay? Later on in our careers as architects, we use that ability to construct in our mind architecture that we envision based on things we learned in school or throughout your life as an architect for that matter, yeah? So the interesting part is that there's only that many pictures that we as architects can ingest in our lifetime. But the neural network can do millions more than we can, yeah? So basically using a similar technique, you're actually able to teach, and here we are again with teaching and learning, a neural network, what is Baroque, what is Gothic, and so on. And we have done that. So we actually created databases of Gothic architecture, of Baroque architecture, not because we want to replicate it, and that's the point where it becomes interesting, but because we can use that as a basis for architecture that is different. If you start, for example, to inform a neural network or ask a neural network, do me a mutant between Baroque and modern, because we also do a modern database, you're gonna get things that don't look modern and they don't look Gothic either. It's something different. And that's where it becomes interesting for me as an architect with a conscious and with a mind and with perception, is that I can say, wait a minute, that image is really interesting. Let me try to pick that out and see if I can really do a completely fleshed out architecture project out of that. So it's not even about the neural network doing the entire architecture. At the moment, I think it's sometimes something that inspires and pushes architecture, or me at least as a designer, it pushes me in a direction that I would not normally do because I haven't thought about it, yeah? But that definitely is like, hey, wait a second, that's interesting. I'm gonna pick that up and really flesh it out as a design, yeah? So I'm not even relying completely on it's not a completely bottom-up thing, but it's not a top-down thing either. It's somewhere in between.
Let me to react to Neil's comment. Let me recall an anecdote. You know, I really understood that I was interested in art or in architecture. I think it was in 1993 or something like that. I have to check. There was an exhibition on minimal art at the Guggenheim Museum in New York. And I didn't know much about art. Yeah, I mean, I used to visit some museums and things like that with my mother when I was a kid, but she was not so much interested in let's say contemporary art or modern art, or more in art in general, let's say, and mostly Renaissance and classical art. And so I visited this exhibition, and then I saw this work by Robert Morris. I sent you the link in the discussion panel. The name of the work is the box with the sound of its own making. So it's an amazing work. You just see a standard wooden box, but inside there were a tape recorder, and the tape recorder diffused the sound of the making of this box. So you hear the sound of the workshop, the guy cutting the wood, putting the nails and all of that. I mean, in fact, it was Robert Morris himself, you know, nailing the box. And this work of art is just absolutely amazing. It's something that had an effect on me that probably nothing else had at that time. And maybe even as today, I believe it's one of the most powerful pieces of art I have ever experienced. And I use this word experience on purpose, because if I would have seen an image of this wooden box, I would have missed, let's say, maybe 95% of the real nature of this artwork, you know. And what I see at the moment, and again, I'm a huge defender of artificial intelligence, and I wrote I think it was maybe in 2009 or 10, or I don't know, that a well-programmed application on a smartphone can produce an architecture which wouldn't be as good as the one of Le Corbusier, but maybe 90% as good as Le Corbusier, and which means that 90% as good as Le Corbusier is thousands of times better than most architecture which is built at the very moment. So I believe that in a sense, artificial intelligence can replace thousands, if not hundreds of thousands of architects or developers building, shit. Let's tell the truth. So I really believe that AI is going to improve the situation of architecture, but we have to keep in mind that who is going to give the small parameters to this AI at some point. And the small parameters to this AI, according to me, again, it's like being able in front of a piece of art, like let's say from Duchamp, or this artwork from Robert Morris, to identify that it's a very interesting and smart and major piece of art. We still have people nowadays who go in museum and who say when they watch Duchamp, you know, they say, it's not art. And I think ultimately the debate is not going to be about forms. It's not going to be about if artificial intelligence is able to create such or such a form, if it's able to create something which looks like Gothic or modern architecture or whatever. Ultimately, the real artificial intelligence that would serve us as architect is an artificial intelligence who would be capable of identifying the Urinoir by Marcel Duchamp as a major piece of art in 20th century history. You know, because if probably an AI would identify this as a toilet. If you train AI on Marcel Duchamp, then it will classify the work of Marcel Duchamp as part of the toilet, you know, toilet apparatus, furniture. So you see what I mean? This is why I really believe that ultimately the ultimate challenge for intelligence is conceptual intelligence. And it seems to me that there will be no other challenges than this one. Is conceptual intelligence associated with consciousness? When it comes to understanding of piece of art, probably yes. And it's probably associated with a very deep notion of experience. But again, you know, it's very difficult to describe what happens when you are in front of a really great piece of art. But for sure, an AI at the moment wouldn't identify Duchamp as something else than toilet furniture.
I have to say something to that, Philippe, because I only partially agree with what you were saying. Because the Gothic and modern example is important because it actually shows that neural networks, and I'm talking about neural networks, not AI in general, yeah, can only work on things we know about. It cannot, you know, what data would, data is things we have on our hand that can be used in order to achieve a specific goal through a neural network, right? The whole problem with neural networks is that it's actually glorified curve fitting. So you have a curve that is defining your goal, and you're trying to get to this goal as close as possible. So a curve fitting of 1, yeah, would give you a modern building that looks like modern. And I'm talking specifically about looks here, yeah. But the interesting part is when you stray away from that, when you don't get close to that one, because that's where things happen which are unexpected and different and unusual and maybe new, yeah. But that actually introduces new knowledge, and that's the important part about it. New knowledge, yeah. things that are not yet in our books, they're not yet defined specifically. And I think that that gray area of non-super specific results in neural network is where the really interesting things happen, where we can, that's the areas, these gray areas is where we can discuss, is there something like creativity going on there? What is creativity? How do we understand it? And by just posing those questions, it challenges us as humans to respond to this new knowledge.
Yeah, but there is also there is also something true that not because it's in a book is truth. I mean, not because a book defines something as Gothic means that it's Gothic. I mean, what is Gothic and what is not, these kind of levels are not totally truth. Because if you start to study more, I am, for example, for my thesis.
Please,
I want to finish. If you let me.
Completely wrong. Sorry, but you just said truth. I didn't say truth. I said knowledge. It's two different things.
No. You said truth. You said that you teach to the computer things that that we know they are true.
Know. Yes.
That we know we are true. Okay. That's my question. That's my question, because they are like kind of idea of that a book is something that you cannot criticize in a way, or that these kind of labels, we cannot criticize these labels. And the truth is that we cannot, in a way, say that something is absolutely Gothic or that something is absolutely modern. And you are talking about visual things that I can also doubt about this visual thing that you are pointing like something that, okay, wait. I would like to know what you define as modern architecture and what you define as Gothic architecture.
That's okay. That's okay. Just two things. First of all, I didn't talk about truth and I didn't talk about books. I don't know where you took that from. Yeah. So just to be clear about that. Secondly, there is of course a bias. The bias is an important part in this whole thing. Without bias, you cannot actually run any sort of database today. But for example, you can automatically search, and here comes the fun part. You can automatically search for images online that are labeled Gothic. Have fun doing that. It's really very entertaining, because the things you get out when you're looking for Goth or Gothic online has nothing to do with architecture. Yeah, it's kind of entertaining. So then comes the labeling process, the bias that is done through that. So if I go through 2,000 images and I put away 1,200 because it's Goth pinups and stuff like that, I will start to look into what my own knowledge tells me is Gothic architecture or not. And we can differentiate here between, you know, Gothic of the 14th century, Gothic of the 15th century, Neo-Gothic architecture. We know there's differences, yeah? But at the end, you will end up with a database that is specifically labeled, yeah? Whether this is labeling done by me alone or by 50 art historians that actually helped me label that database makes a huge difference. And there I agree with you. Yeah, there is bias, and there is, of course, the necessity to understand that labeling a database is nothing that should be done by a person alone, specifically when it's about more general things like understanding what is Gothic architecture. But consider the possibilities of this. Like, for example, let's assume you do a database of like all the Gothic cathedrals in Europe, yeah, and you can train it to specifically recognize features in that database that allows you to recognize unknown pieces of Gothic architecture and say, this was designed by the same person, because now through the comparison, I understand that. That's insightful for the humanities, for example, in architecture history. You should be somebody who understands that the best.
This is good, Matthias. This is a good application of course. But I would say still it's an application which conceptually is not that challenging. It's mostly like the machine has some better capabilities than us in identifying patterns, and we make use of that. It's exactly similar to using dogs to do a person to search for people when there is an earthquake or things like that, you see, because the dogs are much better than us in identifying certain kind of patterns, and more precisely when it comes to dog, it's sensory smell patterns, but a smell is nothing else than a certain kind of chemical patterns. ultimately. All that can be transferred into the concept of patterns. So I agree, it could help, but again, I think that conceptually speaking, it's not a very difficult question. A very difficult question would be the following, again, comparing with dogs. What happened in the mind of the dog when the dog smells you, for example, smells its master? Or what happened in the mind of the dog when he sees such or such scene or such, In fact, I would say as long as we consider AI in terms of pure pattern matching, I'm not saying it's not efficient. On the contrary, I think it's far better than any of us will ever achieve, and it's getting better and better and better because it can have billions or trillions of parameters. It can be trained on trillions of data as well, etc. But I believe that this doesn't even scratch the question of what is conceptual intelligence. Let's say, I mean, it's very Wittgensteinian at some point, this kind of question. But what does it mean, again, to identify or to be in front of a piece of art of Marcel Duchamp or a piece of conceptual art from the 60s? In fact, the AI, just imagine that you train an AI on a huge data set of conceptual art from the 60s. The AI will deduce conceptual art based on images of conceptual art. But then how do you encode the concept? Because the real meaning of conceptual art, of course, it's the concepts that are used in producing conceptual art. So how do you train that sort of AI, I mean, if you train AI on conceptual art based on images, then it's like, it's a complete nonsense. It would be like visual art, or let's say optical art. But that's not what conceptual art is about. Conceptual art is not optical art. You see what I mean? So yeah. There's a very difficult question here, I believe. But practically speaking, there's no question that AI is gonna take over the world, and I would say its power is absolutely unlimited. The only limit I can see, and I'm not even sure if it's a real limit, but the only limit I can see at the moment is pure conceptual intelligence.
Just a quick, short comment only. I mean, I agree with Philippe about the 2D problem that we have in architecture, that, it's basically a lot of the things we're using in AI and architecture are 2D based. But this is going to change within this year, I can tell you, because people are starting to train 3D databases for architecture. And then that, again, is a different story and a different conversation.
Maybe I could invite others who haven't said anything yet if they want to. I mean, I know there's a lot of comments going on in the chat here. I don't know whether Alessio would like to add anything, or Anna, or let me just throw it out there as a kind of comment.
Yeah, wait, hi.
Go ahead, yeah, Alessio.
Hi, Nils. Yeah, I mean, there was a wonderful round of comments and concepts passed along. And I wanted to actually go back to something that was said before about not getting the AI in the place of taking decisions, but just generating, because that's actually something that I'm actually interested into, which is to train a sensibility that takes decision. And with the position that I'm aware that it cannot encompass or it's not trying to reread the entire history of architecture, but just narrowing down to something that I'm interested into, which is considering the entire process of design, a process of a network of decision, a pattern of decisions distributed, diffused between different subjects and intelligences that can be either biological or synthetic alike, and it's more of a cooperation. So training, and of course into that I'm interested into reinforcement learning mainly, because then it trains something to take a certain kind of decision with all the limitation that were just right now brilliantly exposed by Philippe in his argument with conceptual art versus the kind of the kind of stimuli that an apparatus can have, the kind of sensibility that an apparatus can have, and also another consideration that is that I'm convinced of what Philippe said, that in the end you have something that can generate an average quality. Let's say that it's a lot higher than the one that we are used right now, but that will also elevate the standards to what we consider as average. That's what I call the Instagram filter effect. So it's something that it's also AI based somehow. It created a tool accessible to everyone. The quality of the images produced are compared to the, I'm still comparing it to the production of the average of 5 years ago in terms of photography. So it completely redefined what we judge and value as average in terms of photography. And that, I think, will also happen, this kind of adjustment, because our consideration of values, of environment, everything we consider and elaborate is contextual and relative to a certain extent. So our understanding of standards, our understanding of what's the minimum, coming from Maslow pyramid of needs, when you satisfy a need, that becomes something that you take for granted, then you grow new needs become desires, and so on and so forth. Or desire become the needs. So yeah, that was a couple of things that I wanted to put on the table.
Can I just pick up on something there? We've had this discussion about whether artificial intelligence is the right term. You use the term synthetic, and I'm just wondering whether synthetic intelligence would have been a better term. We wouldn't talk about synthetic biology as artificial biology. Maybe it's a different sort of terminology.
Yeah, that was also something, yeah, that reminded me, because so much went on, and some notes that I was mentally taking just went to the back of my mind. And yeah, to that distinction, I think it's a distinction that it's going to be fundamentally create a lot of discussion when it comes to the creation of synthetic organism, about when you get too close to the threshold between synthetic or biologically grown, you realize that I remember all the experiments from Rachel Armstrong with the protocells. I remember all these kind of experiments coming from the Swedish biologist. I don't recall the name exactly, but a lot of things that, or the now the biologists who did create and printed the synthetic DNA, now it escapes the name. I don't recall the name right now, but if, for example, you are able to create an entity, and I think that pretty soon we're going to be able to do just that. Or I'm thinking about the experiments by Alexander Daisy Ginsburg, for instance, to create a biological entity, which means made out of the 4 proteins, ACTG or ACTGU, as they use in the new vaccine that Pfizer is using. So they mimic basically the genetic structure with a substitute that goes with those proteins. So you create a fully biologically intended, for all the scopes, creature, but you're able to program it from head to toe, metaphorically speaking. Is that artificial or is that not artificial?
I think we need to, at some stage, begin to wrap up. This has been a fantastic discussion. I really want to compliment a lot of very interesting thoughts coming out. Actually, one of the things we'll get around to sort of following up with some of these kind of questions later on. I haven't had a chance to respond to Marina's comment about the history question, but one of the things that struck me today, actually, in terms of what's happening, and we're talking about publications and the kind of time lag that exists in terms of publications. What I'm discovering is that I have to submit everything tomorrow for my book, and yet new knowledge is appearing. You know, I'm getting feedback that actually my book would be much better if I could incorporate feedback over the next few weeks. It's been updating in some way, and that's to say that I think actually what's been really useful today is to sense we've got a group of individuals, I mean, many of them very highly significant in the field, and there's me kind of provoking with my naive kind of comments, but I think it's been an interesting conversation in itself. But I think my point would be this, is that in a sense, there's a kind of frontier of knowledge that's moving on, and we got a glimpse today of some really interesting debates. So this has been an incredibly informative thing, and my book is already out of date, right? So, but maybe this is the arena in which we find ourselves fairly soon, in the sense that kind of, well, maybe already, because publications are out of date, that we have to have these kind of platforms and arenas and find somewhere we can bring people together. But I just want to say this has been terrific. I personally got a lot out of this. There are some things we're going to inevitably we're going to talk about in the future. I think that especially some of the comments that Wan Yu's been making about her own practice X cool will come in when we talk about the office itself. And certainly the theme of creativity is something that I think has been central, and that's going to be more central next week when we look at the question about AI and creativity. But I just want to take the opportunity to thank everyone for contributing today. We're going to put this online, and it seems to be almost like this is kind of becoming a new kind of tradition in terms of knowledge, you know, of updating things, which probably next week will be out of date. But any final comments from any of you before we wrap things up?
Well, thanks a lot. It was great. Thanks.
Well, thank you, Philippe, and I
mean,
thanks.
Thank you very much.
Thank you.
We look forward to seeing what Matthias and others are doing in their books and things. And thank you. So, Wan Yu, any final comment?
No, thank you.
No, thank you. Okay, it's great. All right, so just to say that we're going to put this upload this onto the platform. Also uploaded was this incredible 4-hour marathon yesterday that we had with Daniel, which is incredible. Style GANs and cycle GANs. And the comment I made yesterday was actually one of the comments we don't know. We maybe people are unaware of, that Alan Turing himself was a marathon runner. He came 5th in the British Championships in the marathon, and I think that's probably you have to invest in these things. So thank you for this marathon session, and look forward to next week. Thank you, everyone. Thank you.
Thank you, everyone.
Thank you.
Thank you.
Bye.
Thank you. Thank you.
Thank you.
Thank you very much.
Bye.
Thank you. Bye bye.
Thank you. Bye bye.